Every year, billions of felt-tip pens are sold around the world. They're everywhere. In school pencil cases, in offices, in architecture studios, in design workshops. And yet, most of us have never stopped to wonder how this seemingly ordinary object is made. After all, a felt tip pen looks incredibly simple. A plastic tube, a tip, some ink, a cap, nothing particularly complicated. But in reality, every felt tip pen is the result of chemistry, materials, science, industrial automation, and precision engineering. Because a marker has to accomplish something surprisingly difficult, it must store a large quantity of ink, prevent that ink from leaking, prevent that ink from drying out, and then deliver exactly the right amount of liquid for weeks or even months, all while remaining extremely inexpensive to manufacture. Today, we're going to follow the complete journey of a felt tip pen, from raw materials to the very first line drawn on a sheet of paper, to understand how millions of these everyday objects are produced every single day. Before we talk about manufacturing, we first need to understand how a felt tip pen actually works. Unlike a ballpoint pen, it doesn't use any moving mechanism, no spring, no metal ball, no complex mechanical parts. The secret lies in a physical phenomenon called capillary action. Capillary action is the ability of a liquid to move naturally through very small spaces. It's the same phenomenon that allows a sponge to absorb water, or a plant to transport water from its roots all the way to its leaves. Inside every felt tip pen is a reservoir made from porous fibers. This reservoir acts like a microscopic sponge. The ink is stored inside thousands of tiny channels that are invisible to the naked eye. When the tip touches the paper, a small amount of ink is absorbed by the paper fibers. That loss immediately creates an imbalance. Ink naturally flows from the reservoir toward the tip to replace what has just been used. The process repeats continuously. No motor, no pump, no external energy source, just physics. This elegant simplicity is one of the reasons why felt tip pens became so popular around the world. The manufacturing process usually begins with the pen body. Most manufacturers use thermoplastics such as polypropylene or polyethylene. These materials arrive at the factory in the form of small plastic pellets. At first glance, they look like ordinary plastic grains, but they are the foundation of the entire product. The pellets are stored in large industrial silos. From there, they are automatically transported to injection molding machines. Inside these machines, the plastic is heated to high temperatures. It gradually melts into a thick liquid. The molten plastic is then injected under high pressure into precision-engineered metal molds. Each mold contains the exact shape of the future marker barrel. As the plastic cools, it solidifies. The mold opens, and the newly formed parts are automatically ejected. The entire process often takes only a few seconds. In large factories, hundreds of thousands of pen bodies can be produced every day. But manufacturing a plastic tube is only part of the challenge. It must also be perfectly precise. A slightly incorrect diameter could prevent the tip from fitting correctly. A wall that's too thin could crack. Imperfect shape could lead to leaks. That's why every dimension is carefully controlled throughout production. Meanwhile, another section of the factory is producing the internal reservoir. This is probably the least visible component to consumers. Yet it's responsible for holding nearly all of the ink. The reservoir is typically made from synthetic fibers. These fibers are assembled and compressed into a porous structure. The goal is very specific. The material must absorb a large amount of liquid, but it must also release that liquid gradually. Too much absorption, and the ink would remain trapped inside. Too little absorption, and the ink would flow too quickly. Engineers must therefore find an extremely precise balance. Once manufactured, the fiber material is cut into cylinders that perfectly match the dimensions of the marker. Each reservoir is then inspected to verify its density and absorption capacity. Next comes the manufacturing of the tip, and contrary to what many people believe, it's not made from traditional felt. Modern marker tips are usually produced from carefully selected synthetic fibers. These fibers are heavily compressed to create a structure that is both rigid and porous. The final shape depends on the intended use. Drawing markers often use fine tips. Industrial markers use thicker tips. Highlighters typically feature chisel-shaped tips. This geometry directly affects the writing experience. A difference of just a few tenths of a millimeter can completely change the feel of the marker. The tips are cut, calibrated, and polished. Optical inspection systems then verify their dimensions, because even a tiny irregularity could affect the ink flow. No component is as important as the ink itself. This is where the most secretive part of the manufacturing process begins. Many manufacturers protect their ink formulations as closely guarded industrial secrets. Depending on the intended application, the composition can vary significantly. School markers typically use water-based inks. They produce less odor and are easier to wash away. Permanent markers rely more heavily on alcohols and other solvents. This allows them to adhere to surfaces such as metal, glass, and plastic. Ink production begins with the mixing of ingredients. Dyes or pigments provide color. Solvents ensure proper fluidity. Various additives improve stability, shelf life, and resistance to fading. Every ingredient must be measured with precision. Even a small deviation can alter the behavior of the final product. The ingredients are blended in large industrial tanks. Powerful mixers keep the solution perfectly uniform. Technicians then collect samples for testing. They check the color, the viscosity, the stability, and even the drying speed. Only after passing these quality tests is the ink approved for the next stage of production. Once all the components are ready, assembly can begin. This is often the most impressive part of the factory. The different parts arrive automatically on conveyor systems. The plastic barrels are oriented. The reservoirs are inserted. Then comes the filling stage. Precision dosing systems inject exactly the right amount of ink. The reservoir immediately absorbs the liquid. Within seconds, the ink spreads throughout its porous structure. The tip is then installed. It is placed in direct contact with the saturated reservoir. The ink delivery pathway is now complete. The cap is added. Sometimes it includes a ventilation system designed to improve child safety. Some production lines are capable of assembling hundreds of markers every minute. Result is a remarkable display of industrial efficiency. Thousands of finished products move continuously through the factory without interruption. But before they can be sold, the markers must prove that they work properly. Quality control is everywhere. Some machines automatically check the weight of every unit. An incorrect weight may indicate a filling problem. Other systems verify dimensions. High-resolution cameras inspect every component. Writing tests are also performed. In some factories, robotic systems draw standardized lines on sheets of paper. A customer should have exactly the same experience with any marker produced by the factory. Once approved, the products are grouped together. The markers are sorted according to color and model. They are then placed into individual packages or multicolor sets. The boxes are automatically sealed, labeled, scanned, and stacked onto pallets. These pallets are transported to massive distribution centers. Some will travel thousands of kilometers before reaching store shelves. A few days or weeks later, the markers finally reach their destination. A child drawing a picture, a student taking notes, an architect sketching a design, or an artist creating an entire work of art. What makes the felt tip pen so fascinating is that such a simple object combines an extraordinary range of technologies: precision plastics, advanced fiber materials, complex chemical formulations, automated assembly lines, sophisticated quality control systems, all working together to produce an object that sometimes costs less than a single coin. The next time you remove the cap from a marker, take a closer look. Behind that simple line of color lies years of research and millions of industrial operations, all working together to transform a few drops of ink into an idea on a blank sheet of paper. And perhaps that's what makes the felt tip pen so remarkable. A complex technology hidden behind an incredibly simple gesture